three rods of identical cross-sectional area and made from the same metal from the sides of an isosceles triangle ABC, right angle at B. The points A and B are maintained at temperature T and square root of 2 multiplied by T respectively. In the steady state, the temperature of the point C is Tc. Assuming that only heat conduction takes place, ratio of Tc upon T is given by. So this question is also based on the simple concept that the heat flow is going to take place and it is based on the conduction itself. So let us first draw the rods which are arranged in isosceles triangle and which is right angle at B. So this is our isosceles triangle, right angle at B. So let us suppose this is our A and this is our C, and this is connected like this. And it is given that the points A and B are maintained at temperature T. A is having a temperature of T and B is having a temperature of square root of T. So obviously we can see that the temperature of B is on the higher side as compared to temperature of A. So the heat to point A will be flowing through two paths. One will be directly from B to A and another one will be from the path using the point C. So first of all it is going to from B to C, then C to A. And we are supposed to find out the temperature of point C is Tc. So this is given as Tc and we are supposed to find out what will be the ratio of Tc with respect to T. And both A and B contains a factor of T. So point C comes only in the picture when the heat conduction takes place with this to point A while we move from B to C and then to A. Okay. So in this way only the point C comes into the picture, otherwise B to A is a direct, we can say, conduction of the heat. So we start from there only, that the temperature of B is greater than temperature of A. Temperature of B is greater than temperature of A. Therefore, the heat conduction takes place between the 2 points, to the point A using two paths. You can say from here that heat conduction takes place through two paths. To point A. One is a direct path which means directly from B to A, and second is our indirect path which is from B to C and then it goes to point A. And in this case it is isosceles triangle, so we say the length of AB is L, so BC will be also L, and the length of our AC will be square root of 2 multiplied by L. So we are only interested in this indirect path. And in the question it's also given that the rods are made of same material, so that's why they are going to have the same conductivity, thermal conductivity rather, which is denoted by K. So we can write that since the rods are made of same material they have same thermal conductivity. They have same thermal conductivity, that is nothing but the value of K. And we are only interested in the indirect path. Okay. So let us find out the, you can say, the heat flow equation. For the first path we are going to take from B to C, and second path we are going to take from C to A, and then we can use their balance equation. So we can say that thermal through indirect path B to C, and let us call that heat conduction HBC from B to C, and the equation for heat flow HBC, we can say equation of heat flow gives us that our HBC will be equal to A multiplied by K. A is the area of cross section, which is also same for all the three rods, and divided by the length, that is L, and difference in their temperature, that is TB minus TC. And we substitute the value because TB is given to us, and we can write that our HBC is equal to AK upon L, and TB is given as square root of 2 multiplied by T minus TC. Let us call this as equation 1. Similarly, we do it for equation for rod CA, because now the path is for CA. So we say HCA from C to A. So we can write the equation that HCA will be equal to AC, sorry, not AC, but AK. Length is square root of 2 multiplied by L. Temperature of TC minus temperature of point A. We substitute the values. We get HCA is equal to AK and square root of 2 multiplied by length A. Temperature of C is given as TC and A is T. Let us call this equation 2. At steady state, the equation 1 will be equal to equation 2. Okay. So we can say at steady state, heat entering to C from B will be equal to heat leaving from C to A. Heat entering to C from B will be equal to heat leaving from C to A, or in the shorter form we can say that our HBC will be equal to HCA. So now using equation 1 and 2, using equation 1 and 2, we substitute the equation, and we already know that AK upon L, TB is our square root of 2T minus TC is equal to AK upon L, A square square root of 2 here, multiply by L, and this comes as our Tc minus T, and this is K, and our AK and length cancels out, and cross multiply, we get this as 2T minus square root of T C is equal to Tc minus T, and that is quite easy now. Simplification, we can write this as 3T will be equal to, this comes as Tc and square root of 2 plus 1, and we are supposed to find out ratio of Tc to T. So from here we can write that our Tc upon T will be equal to 3 divided by square root of 2 plus 1. So if we check the options that are available to us, we can see that the option number B is the correct option, Tc to T. So option B is correct. B is correct. So this question was quite simple, directly based on the concept that heat entering from one point will be equal to the leaving point, leaving from through that point. So this completes the question. Thank you.